Hello everyone, welcome back. So, as was discussed in our previous video, rules to draw ray diagrams for concave mirror. Now we are going to see about convex mirror. So let us start with rule number 1 so quickly. So let us take the convex mirror first, the diagram of your convex mirror, and then we will go ahead with the rule. So assume that the convex mirror is considered over here, and now the silvering. So this is just a spherical surface, right? So silvering, without silvering we cannot say it as a spherical mirror or a mirror directly. So now this is your convex mirror. Now what we can have now? Principal axis. We should have now the principal axis. So like this. So this is your principal axis. And then this principal axis passes through well-known the geometrical center, pole, and the center of this sphere, center of curvature, and then we will have a focus F. So done. These are the terms related to your convex mirror. So I would like to replicate this one for the other rules ahead also, so that it will be easy for the diagram. So I'm just taking as a precautionary step the starting only, all the 4 type I will just to consider. So now the rule number 1. So what is rule number 1? Straight away let us write the rule. So the previous concave mirror only, the same rule will be taken. So any light ray passing parallel to principal axis. Clear? Any light ray passing parallel to principal axis. So after reflection, as this convex mirror is a diverging mirror, after reflection it appears to be diverging from focus. It appears to be diverging from focus. So as the convex mirror is a diverging mirror, we will consider that the light ray appears to be diverging from your so-called focus. So say this is your light ray passing parallel to principal axis. So one above and one below. So as previously I was made out. So now what we said now directly just now, that it appears to be passing or diverging from the focus. So appears to be diverging from focus. So I would like to take a dotted line over here to show that it is appearing to be diverging from focus. Now the reflected ray will be in this way, like this. So it reflects such a way that it appears to be diverging from focus. Clear? So this is your rule number 1. And next, rule number 2. As you already know, it will be the reverse of rule number 1 straight away. So let us take this one first. So what is rule number 1? The light ray passing parallel to principal axis, right? So now here, this is going to be light ray appearing to be passing or entering into focus. Any light ray appearing, any light ray appearing to be entering into focus, after reflection. Now you can guess it. Very good. It goes parallel to principal axis. It goes parallel to principal axis. Very good guess. Right. So what do we say now? Any light ray passing or appearing to be coming into focus or entering into focus. See here like this. So light ray appearing to be entering into focus. So one light ray over here, and I would like to consider one more light ray over here. Okay, na? So we need this one to be appearing to be entering into focus, right? So appearing to be entering into focus. So how you can show that appearing? With the help of a dotted line. Good. So now let us take the dotted line. Say it is appearing to be entering into focus. So what will happen then after reflection? After reflection, it goes parallel to principal axis. Exactly reverse to the rule 1. Clear? So any light ray appearing to be entering into focus, after reflection, what happens? It goes parallel to principal axis. In this way. Right. Next, rule number 3. So I think we are just completing it very quick, right? Very good. So rule number 3. Same as usual in the previous concave mirror. Here also the same thing. So any light ray appearing, see everything are assumed, appearing to be entering into center of curvature, entering into center of curvature. After reflection, as usual, it retraces its path. After reflection, it retraces same path. So same reason you can say. What is it? Incident along the normal, angle of incidence will be equal to angle of reflection. So see here now, any light ray appearing to be entering into what we call center of curvature, right? So any light ray appearing to be entering into center of curvature. So say this is some kind of appearing to be entering into center of curvature, and over here also appearing means you will be having a dotted line. So now any light ray appearing to be entering into center of curvature. So it is coming in this way. So therefore any light ray appearing to be entering into center of curvature, based on our rule that angle of incidence is equal to angle of emergence or reflection, it retraces the same path when it is incident along the normal. So what I can say, I is equal to 0 degrees is equals to R since incident on normal or incident along normal. The same old reason you can say for this. Okay, good. Next, rule number 4. So rule number 4 doesn't change from concave mirror. Okay, na? So what is that here? Any light ray incident at pole, any light ray incident at pole making an angle theta, making an angle theta, it reflects, yes, very good guess, with same angle theta, because we already know that angle of incidence is equal to angle of reflection. So you are very good saying the correct ones. So now a light ray incident at pole making an angle theta. So again it will reflect with same angle theta. The reason is angle of incidence is equals to angle of reflection. So hope you all understood, right? What sort of this, all the rules are there. So once again let us recall. Rule number 1, any light ray passing parallel to principal axis, after reflection it appears to be diverging from focus. Rule number 2, any light ray appearing to be entering into focus, after reflection it goes parallel to principal axis. Rule number 3, any light ray appearing to be entering into center of curvature like this, as it is said to be incident on the normal, angle of incidence is equal to angle of reflection, that is 0 degrees, it retraces the same path. Rule number 4, light ray incident at the pole making an angle of theta, that is angle of incidence. It also reflects back with same angle theta because angle of incidence is equal to angle of reflection. So hope you all understood, right children? So thank you very much. Have a great day. Any doubts, so please do text me in comment box. Thank you all.